Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter written in Swift. Happy St. Patrick's Day to you if you celebrate that. So where we are, we talked a lot about parsers at the end of the day yesterday and kind of figuring out what to do next and how to get operators in there. And I think what we're hitting is a wall of parsing versus semantics. And let me show you what I mean by that. Let's see, I kicked off a test, so that'll catch up to us eventually here. So the big challenge we have, let's see if I've got the rule written out somewhere. Yeah, so we have this notion of basically you're making a function call or a definition. And so you have a bunch of expressions and then optionally followed by equals and expressions. And if you see the equals expressions, then this was meant to be a function definition. And if you don't see the equals, then it's meant to be a function call or a statement to evaluate, like 7. Okay. The challenge here is that expressions basically boils down to one or more expressions. No surprise there. Expression plus. And a single expression is things like int, float. It could be a function name followed by arguments. It could be an uppercase name, a parenthesized expression, a lambda expression, all these things. All right. And the challenge of this is, from a parsing point of view, it's not a challenge. I mean, we can define a series of expressions equals expressions, and that's fine. But if you're making a function call definition, these expressions have to be simple names. So it has to be like function of x, y equals x plus y. And you can have as many as you want in here, and that creates a bit of an issue. So I don't know until I've parsed a bunch of expressions, is this a definition or is this a function call with a bunch of arguments? And that puts me in a quandary from my semantics point of view. If I knew I was looking at a definition at the beginning, then I could go down the path and make sure that the function of x, y, z, all those can be single or lowercase names, and you can't have fancy expressions or any of that stuff, and then your equal sign, and then any kind of expression you want. But if it's an evaluation expression, then it can be arbitrary. 3 plus 2 times parentheses a times b, kind of thing. And we can't tell until we get to the end or to the middle where that equal sign is, which one we're dealing with. Because you could have a perfectly good function of x, y if function is defined to take 2 arguments. And so what that means is it's hard to say the exact, like, how do I interpret this thing? Well, everything I want to do in normal expression evaluation is completely the wrong thing to do if I'm defining it. And so that means I can't really make a decision until I see this equal sign. And then when I see the equal sign, oh, now I know how I was supposed to parse all that stuff. It was only supposed to be names, and I don't know. So the way around this, well, okay, what we're doing. So right now we keep track of left-hand side, right-hand side as the 2 sets of expressions. We don't know, was this left-hand side constrained to only be lowercase names until we see this equal sign, which means we just parse them and hold them. And then at the point we see the equal sign, now we can apply semantics. If it's an equal sign, we can say, hey, check that all those things were, proper names like they're supposed to be. And if it's an expression, we can say, oh, you should have structured that into a big old tree and evaluated it. Now we could allow the evaluation. I mean, that's the tricky part. The problem is the evaluation is also complex. And because of this currying idea, you can have, well, we did all these examples yesterday with function of, x let's see, what was the exact, we had a 2-argument function. I'll bring up a REPL. That's the easiest way. Okay, let me hide that green. Woof. All right, so Elm Ripple. So we can say function of x, y equals x plus y. And on the left-hand side, we're restricted to all names. And on the right-hand side, we could be arbitrary expressions. Okay, so we've made a function definition. Now we can say function of 3, and that's a function. Basically, we used the first argument, we plugged that in, and now this is a 3 plus whatever function. Okay, so what's left is sort of the equivalent of function y equals 3 plus y. Okay, and let's make some names. So m equals 3, n equals 4. I can say function of mn, right? And if you're the parser reading along, you read that and you don't know at this moment, is he evaluating this, which I am? Oh, it's a number. Or was he just about to type an equal sign and make a new function definition? Okay. Yeah, well, it's bad luck. It's legal, but bad luck to shadow the variable names. But you didn't know what I was doing, right? So until he applies semantics, and the semantics are look up the names in the symbol table. If they're already used, that's at least a warning. If it's a function, like I already had function m, well, I had function, let's see, function 3, 4, is it times or plus? It's still plus where I started with. So apparently that's an actual syntax error. So, you know, it's as the parsing is fine. I can parse expression equals expression. But when I start applying semantics, I start saying, hey, was this all names? And does it have an equal sign? Oh, it must be a definition. Check if they've already used these variables. If it doesn't have names, I don't know, can I say function mn again still? Yeah, if it doesn't have names, well, it's a function call, and do that. And how do you know how many arguments to give it? Well, look up function in the symbol table and decide what kind of function it is. So, I don't know. So where that leaves us, what I think is going to happen, I think, excuse me, I think we can't really do the job of this thing until we know whether it's a definition or not. And so I think returning the left-hand side probably is insufficient. I don't know. We also looked at those currying ones. So we looked at, let's try function 3 plus 4. Yeah, doesn't like that. Okay. So, you know, I don't know if we can do 3 plus 4, 7. Yeah. It gets confused because it thinks function of 3. It says function. I can take one argument there. Now I have a function of 2 arguments, and you try to do a plus at me? What the heck, you know? But I can do function of 3, 4 plus 2, plus 2. So 3, 4 is 7, plus 2 is 9. Yeah. Okay. And even if I write it 3, 4 plus 2, it's like, no. It's function of 3, 4. Take that and add 2. I find that confusing on Elm's part. I don't know. Once in a while I get these little syntax glitches that I go like, why? What's the benefit of that decision? You've made things very hard to understand. I mean, I definitely could see myself making this bug. But anyway, so I think what we have to do is figure out how to get expressions in there, defer thinking about values until we get, well, down here or here. I mean, variable equals left-hand side as variable. I mean, it's not a variable. It could be a lot of things. we have to decide if it is a variable. If it's not a variable, it's an error, Okay, so that tells me we have to do semantic work up here to do this. Unfortunately, I think we may have to do semantic work to finish parsing, and that's really unfortunate. So that's kind of what I was trying to do here. Lowercase name with its own expressions, you can have as many arguments as the function has, up to as many arguments as the function has. That's not enough, because lambda expressions are also functions that take arguments. And I don't know, if I replicate that down here. Okay, let me make an example of that. So if I do lambda x goes to x plus 2, I can do that. I can also put it in, I don't know what happens if I don't put it in parentheses. Let's take that first. 3. Okay, so it got a little confused, but if I parenthesize, then this thing coming out of, coming out of the lambda, the parenthesized one, is a lambda expression evaluating something. It should be fine. Yeah. So the deal is I have something that is a function. It's not just like you look up the variable and it turned out it was a function, which is the first case. I've got an actual lambda and it's a function and it takes an argument. Now, why this is not legitimate? Yeah, I'm not sure. Lambda x plus 2, 3. Right, so it's almost like it doesn't notice. I don't know. It's a little weird. I'm not sure I've got a grammar that can catch that or not, which is not good. Are there, okay, too many arguments. X plus 2, 3. Let's simplify it. Huh. Number goes to A. Goes to A. Okay. Lambda x goes to x3 applied to 7. The argument is a type number, but it needs the argument to be function. Oh my, okay. Lambda x goes to lambda, well, x is okay. Lambda x goes to x, gives me 3. Lambda x goes to x plus 1, gives me 4. Yeah. Huh. Wow. So something's, I don't know. X3 thinks it's a function call. Why didn't it think this one was a function call? I guess because x plus 2 has to be an int, and ints can't take arguments, so it's not. Yikes. Okay. Ugh. Boy. Well, maybe the place to start is the definition. I mean, the constraint we have right now, we don't know how to handle any definition except a simple definition: x equals 3, m equals 7, and so on. Okay. Wowzers. Okay, so one thing we could do is Oh, well, yeah. So right now we only handle simple definitions. We don't even handle uh, lambdas. Like this could be multiple expressions again, right? It could be lambda x, x plus 3, applied to 4 or something like that. Well, I think the constraint that has to be well, we're getting into what does it mean? As we should, I guess. If I do f of g h, I don't know, x, y, can I do that still? Function of x, y equals something. I believe my constraints at this point are the name. I think function x, y equals x plus y. Okay, that's a 2-argument function. I believe that is the equivalent of function equals lambda x goes to lambda y goes to x plus y, and that we're basically going to translate the function definition to this lambda definition. We don't care what the parameters are per se. I mean, they get used in that expression like a lambda. So this definition is legit, and it's the equivalent to the one above it. I don't think you can do them in a row. Lambda x, lambda y goes to x plus y. Yeah, okay. You got to have the arrows. Okay. So that tells me my definitions. Maybe let's tackle these definitions. I think that's a good thing for today. Okay. I know it takes me a while. All right. So I think what we're saying is, well, we'll leave this expression for now, but if you get in here and you're ready to make this thing, we want to make sure that the left-hand side, he's not a variable. Oh, he's an expressions. What is that? Oh, we've translated into a function call. Okay, that's just not going to do. Wow. So we're pretty tangled here. Okay. Because what I want, I think what I want is this. I want to get the expressions back. And then up here, I want to make sure everything in the list is a variable. And if it is, then I'm going to make a definition and I'm going to put my lambdas in and all that stuff. Okay. So, right. So the problem is, I think we're going to introduce a dummy node. So right now, expression, we don't have anything that represents a list of expressions. And I think we're going to do that. And our definition will be happy with that. And then we can, if the function call semantics is right, which it's not quite right, but to the extent it's the right thing, we can deal with that in here. We can replace this expressions with some other expression that maybe is a function call, maybe is other things. Right. So here, yeah, we do if the expression count is 1, then it's just a simple expression, 3 plus 4. You evaluate it, you're done. Otherwise, it must have been a function call. That's a bit naive. Okay. Let's see. So expression function call. All right, so I think what I'm saying is what I want to do to change this around is I'm going to make the expressions return an expressions node, or maybe multiple expressions, just so I don't confuse myself too much. Returns multiple expressions, which is basically wrapping the array of these things. They're probably not useful in that form, but they're useful for this thing to decide if they're all variables, and then they're going to be useful down here to basically execute this logic and decide if they're simple expressions. Okay, that is a refactoring at the moment. It's a moderate one. I'm not intending to change behavior yet. All right, so let's look at our nodes. Okay. So what's similar? I don't know. Maybe a variable. And nodes themselves, variable. Okay. This order is not helping me any. All right. So we have an expression. It's been a while since we did one, but you have to give it an initializer that knows the type. You have an EQ function and an evaluate function and an add string. Okay. So let's drive a multiple expressions subclass of expression into place. Okay. So down here, we're going to create a new file. I use John Reed's test case one. Yes, this goofiness here, unbelievable. Multiple expressions. Okay. This should really be multiple expressions tests. Okay. And, well, we can run this just to make sure, but it would be shocking if this actually does not fail. Okay, so, I lost my variable. Let's see, that one's up. Why Xcode thinks the last file I opened is the one I want to go away first, I will never understand. Okay, so we're going to create one. We don't need a name, but we will have to give a type, which I think we'll make unknown for now. We need to test this EQ function, and we need to test evaluate and add string. Okay, so let's drive one into place. Did that not test? Did that not run? What happened? Okay, there we go. Maybe I just built. Okay. So let's test well, add string is probably the easiest. So let's do that. Test add string. All right, so what we're going to do is we're going to create a multiple expressions. Okay, and we're going to, I guess, add do we have to know them before we create them? Maybe that would be the easiest. So you have to give it the expression. I'll just give it variable x. Okay, so That's the list of expressions it gets. And we would like assert equal that expers.asString. Actually, I should do description. What did we test before, I wonder? Well, description is multiple expressions of, and then I think just X. We'll take a look at his variable. Oh, he says variable name. Okay. Well, what we can do, and this is this isolation pattern from James Shore that we talked about. We can say, well, I'm gonna I'll use the inner thing to just give me its information, and then one last thing I got to do. Okay. So inner expressions is that, and I can do inner expressions sub-0 dot description. Okay, so I'm making this trade-off that if variable X ever changed the way it printed its description, this test would be robust against it. The flip side is this test is assuming it knows how to get that value out. But I think you know, given the things of what's going to change, it's probably a good trade-off, because the description of the big thing is probably going to include the descriptions of the little things. Yeah, I don't think there's any problem there. All right, I don't think I can create the class here. Okay, so all right, multiple expressions. It goes in here. This is just a Swift file. I'm just going to put something to get it out of that crazy mode. Okay, this is expression, multiple expressions. It's an expression. Okay. And that should tell me I got to do some overrides. No? Okay. I'll give it an init. And the init is going to take inner expressions, which is an array of expression. All right. And then I have to call super with some type, and the type we'll use is Elm type dot unknown. Okay, so I'm not evaluating things in this expression yet. I'm just you know, just doing it. Okay, just passing them in, holding them for now, and then I'll put a type on it later. Okay, this test should fail. Unfortunately, Swift, well, I shouldn't say unfortunately, Swift's way is to not have abstract methods that you must override. And so that means that we don't override them, and then we come in here and find out like, oh, wait, there's a problem. Okay, so how did this fail? Well, he got question mark, question mark, question mark. That's the parent method, the default parent method. It would be nice to change that maybe, but let's push on this first. Okay, so we need an as string, returning a string. And I believe this is an override. Okay, so let's return multiple expressions of something. And let's just make sure we're on the right track here. Probably should run the one test. Okay, so now we just get this, but we want the inner expressions as well. Okay, so let's let the inner, we're going to take the inner expressions, which we didn't save. Let's save those. Let inner expressions be array of expression. Okay, since we define it in there, that's fine. Okay, so now if we take the inner expressions, map each one to its description. Okay, and then joined with a separator of comma space. Okay. And this is inner. One more. All right, so take each inner expression, make its description the way it wants, join it with a list of comma, make it a comma separated list. And I think that should do it. So this is kind of a weird mix of TDD. I mean, it's I mean, I'm driving these things in to get a proper, did you run? I'm driving them in to get a proper new class for this thing, but the whole point of it is to get this thing so I can plug it into my existing stuff. Multiple expressions variable x is not equal to, I left off a parenthesis. Okay. You know, we're trying to build this new class that's sort of equivalent to the stuff we have holding it now. And once we've got this thing driven out, we'll put it in. So it's kind of not test driving in a sense, because I've already got the design I want. I know it has to be this class with these 4 methods overridden, doing the right stuff, but it's being created for the purposes of plugging in and wrapping over an existing thing. Anyway, let's see, our variable, we lost our variable tests. Let's see, we got equality is a good one. I guess I should probably be looking at expressions, right? Expression. Let's keep him alive. Hide the parser for now. I guess my to-do doesn't reflect what we're doing. So I think what we're doing is, I don't know, we're doing a refactoring, very odd one. Introduce a multiple expressions class, defer semantics until we know whether we have a definition or an expression to evaluate. Well, that's going to overflow. Okay. Alrighty, so if we look at expression, we've covered this. I think this is unfortunate. This, I think, really should be like this one. Didn't override as string, and then this is now as string. I don't think this affects tests because we're not checking that the expression class acts like an abstractd class, but I don't know. And the prints are a little weird. You know, if I had I mean, in Java, where you can just throw hardcore exceptions without declaring throws, I would do it. But I really hate polluting all my functions with throws, and it's going to complicate other stuff. So this is my compromise. Return something goofy looking, return something, likely to be a problem, and print a message and hope I see it. I think so far it's been okay. So I guess it's just my way. But I do need to do EQ, and again, I'm going to look at variable, just seeing what they override. Yeah, so EQ evaluated as string. Let's handle EQ. I think that's a good one. All right. So test EQ. All right. So we're going to make expressions that are equal and expressions that are unequal. And I don't think it has to be too hard. So let's try let expr1 I kind of do this, I guess. expr1a equals multiple expressions, and we'll just give it something integer value 42. Good number. All right, we'll make an expr1b that's the same. And I don't know, maybe I could put a couple values in there. Just to make sure it's looping. Okay. So now I want to make things that are not equal. All right, so EQ takes expression. So we can make some that are different types. That should certainly not match. Whoops. Let's see. 2a equals integer value is an expression. Well, we'll even do this. Okay. It doesn't match. Now let's get one that is the same type. And I'm just going to swap these values. And that'll sort of demonstrate that order matters. Okay. So I want to have one that's equal, and then kind of on every parameter, I want to make sure there's a variation and it doesn't work. Expr2b. Okay. And then I should be able to say assert equal expr1a. Well, I guess I'll assert true and just do EQ directly. Okay, so expr1a should equal expr1b. Can I try an integer? Okay, and it should be false for the others. expr1a equals expr2a and 2b. Okay. My true failed. Okay. Well, we'll steal that. Okay. EQ, if the other is a multiple expressions. Okay, if he's not, it's false. If he is, we're going to look at inner expressions. Other dot inner expressions. And the type it's always unknown, but it should still be equals. Kind of deferring. Maybe I should be saying super.eq there. Would that be better? We'll take it under advisement. Okay. Let's get it working first. And I think this will pass, and it does. Okay, so, right, let's say add multiple expressions of type expression with, we've added as string and EQ. Okay. Let me add a task. This is a refactoring. Should EQ use super.eq? All right, we'll save that for when we get this thing the rest of the way done. All right, and then there's one more. Evaluate. I think for now we just return an error expression. I don't think anybody's supposed to evaluate this directly. Yeah, let's write the test first anyway. Function test evaluate. Because I think if we're just using this to defer calculations, we're just a holding place, and whatever we produce from that holding place is gonna be the real deal. All right, but we need an expressions. Well, and assert equal. If we call expressions.evaluate with a symbol table. Well, actually, we could use the capital one, couldn't we? Well, we don't care what it is. We expect to get error expression. And I think it took an argument. Error messages dot. Let's see what this thing is defined as. Location. Okay, we don't know the location. And this is error messages dot. Let's say cannot happen. Okay, and I'm going to split these lines. Error evaluate symbol table. Error expression. Yeah. Okay. This should fail. Oh, we don't override evaluate, so it's certainly going to fail. Succeeded. How did that? I guess expression must default to cannot happen, right? Where is evaluate? Cannot happen. Okay. Well, that's probably okay. I can override that. Well, maybe I don't need to. Maybe that's okay. All right. It's a good time for a break, so let's take a couple minutes. We'll come back, and I guess we'll see what we want to do. I think maybe I'll do that refactoring we mentioned and make instead of everybody testing the type directly, let's just let the super do that job. I think that's actually a good job for it. And as far as he's concerned, yeah, let's make that happen. Okay, so 2-minute break and come back again. Thanks. Hi, welcome back. All right, so we're going to jump ahead on our to-do and let's apply this refactoring. I don't know. I definitely considered it before, but I think maybe it does make sense. So if I do that here, then I want to say EQ is super.EQ of other, and this, and the self.type thing should be coming from the parent class. This is going to fail. Right? Yeah. Okay. So it did not come up equal because it always returns false in the parent, the EQ. But I think we can say we legitimately do know the type, so I don't have a problem with going there. So if self-type equals other type, okay. I don't know. Is it any better to say this? I think it's a little more idiomatic to do it this way. So I'm saying if you compare two expressions for EQ, as far as the superclass is concerned, if their types match, they match, because that's the only thing it tracks. I think that should fix this. And I did it this way to kind of force the failures so I could see see the change working. But now on my other ones, I feel like I can just plug it in. Okay, so let's go down the expressions. Empty expression, well, he doesn't care. Okay. Error expression is funny. He may not care. Yeah, those two don't really matter. This one though, I think we want to say super.eq other and self.value equals other value, and then take this off the end. Okay, and I'm just going to do them. And self-value equals other value. So we're getting the internal stuff. Okay. So I'm just peeling off the type equality. All right, if expression. EQ, so this is super.eq other and this, but we can drop that. I guess we'll do half symbol tables, not an example. Okay, let's run these. These should all pass. If expressions should be modified. Yep. Okay, and let's go ahead and finish them. function call has a list of expressions. Well, I would say his type should still match his parent type. We'll have to watch if function call breaks, but I don't think it will. All right. Okay, so this is a refactoring. Make subtypes call super.eq other instead of looking at types themselves. Okay, well, there's something. Okay, let's capture that. Refactoring, okay. All right, now we've got this multiple expression class. Defer semantics till we know whether we have a definition or an expression. Okay. So this, okay, I'm just going to close all these. Let's open up multiple expressions. Okay, and let's open up the parser. Oops. Let's open up multiple expressions again. Lock it in. All right. So where we have expressions, the only place it's referenced, I believe, is there. So let's check that. Maybe some callers. No. Okay. So if return error. Okay. That I think is probably correct. If any expression fails, we just want to say this thing failed and go on. But what I'm going to do, okay, so I'm going to say let multiple expressions, if you'll forgive me the abbreviation, equal a multiple expressions with the expressions. All right. And now I want to use that. What I'm trying to do is rework my exit sequence. So if I let you access the expressions, which I guess you can, if instead of the expressions.count, I look at multi-expressions.inner.count, we'll get better. Sorry. All right. And then I'm going to return multi-expressions. Come on. Multi-expressions. You're going to make me type it. Inner expressions sub 0. So we were trying to get to the expressions. We've wrapped those in multiple expressions, and now we're pulling them back out directly. And then this one, the expressions, is really multi-expressions dot inner. Okay, that I think should be a refactoring. So I mean, it seems a little goofy. I'm wrapping this type up in this thing, and then I'm immediately pulling stuff out. But what I want to do is, since multi-expressions is an expression, I can take this part out And let me comment it out first. Okay. Whoops. If I return multiple expressions here, and then wherever I returned it, I put the stuff that came right after it, then I should be equivalent. So I was multi-expressions. Now, multi-expressions is what we called LHS. Okay, so I'm going to change the name. Well, I'll change it and then change it again, I guess. All right, LHS. Okay. Instead of returns, let me change this name to expers. Expers. Now the returns, I'm going to say let LHS be of type expression, and then I'm going to assign it in the two paths. Take the return out. Okay, can I convert value of type? Well, let's make this multiple expressions. Still an expressions object. Okay, and then I don't need this. Okay. My claim is that muck of a refactoring, I was really basically pulling out the whatever followed the end of the expressions calculation I have now and trying to get the same effect. So instead of returning inner expression sub-0, I'm assigning that to LHS because the original, that's what it did, is assign that stuff. Let's see if this works. Always good before I start spouting off about it, but I believe it should pass. Failed. Okay, that didn't build, or okay. Let's see. I'm gonna be pickier on this. As multiple expressions. Oh, I don't want to get too messy. I'm trying to do this safely, and here I am mucking around. Experts is now optional. No. Okay. Let's do this. Okay. If let's let first result equals expressions. If first result is error expression, return first result. Okay. Otherwise, let expers equal first result as multiple expressions. Okay, I promise I will get this cleaner, but let's get it compiling first. So now I'm peeling out that it could have returned an error expression or multiple expressions. That may be a mistake, and maybe the expression, the error stuff should be pulled out as well. All right, but let's get it let's see, it's working. Okay, so we've successfully rejiggered this function. Let's do this. Okay. First result equals expressions. If error equals first result dot first, if error has any errors, sorry, if the expressions has any errors, first result equals expression has no member. Oh, it's the actual things. Okay, well, we'll leave it what we had then. Okay. I'd like to get this paragraph from 75 to 84 into like 2 or 3 lines. Okay, how do we... I'm terrible with Swift syntax. Do I have a sheet? No, somewhere I have a Swift cheat sheet. It's like if... Okay, so if the first result is error expression, that's correct. I think that's the only easy way to check that. Then we get the result as multiple expressions. Well, let's at least do let's at least do this. If expers enter is count, then this else else that. That's a lot of mucking around, isn't it? This is what I mean when I say doing the errors makes it hard and doing the semantics makes it hard. Okay. This should be a refactoring still, believe it or not. Well, that one all I did was make a question mark or ternary operator question mark instead of the if statements. I think it would be confusing to put the inline the expers there. Okay, so we parse the expressions. Now I'm going to move this down. So I'm trying to push the semantics towards the bottom. No, I don't have an LHS yet. That's got to happen first. Okay. Well, the LHS is expressions. Maybe I can pull this down. That is really this. if it's going to be a variable. Okay. Let's make sure. All right. Okay. So tests are passing. You return multiple expressions object rather than let's just say return multiple expressions object from expressions. Okay. Now I think we're ready to enforce some different stuff. So what I would like to enforce, instead of this being a variable, I mean, what I want to enforce is that everything in that expressions list is a variable. Name equals expression. So this is function or variable. Okay. I think we're green. All right. So I think the test I want to make is a function definition must only have variables on the left-hand side. All right. So let's put that in our story. Multiple expression, defer semantics. Yeah, I think we've done that. That's why I moved that down so that those enforcement would happen down there. Okay. Now the story is a definition must only have variables on the left hand side of the equals. Okay. That seems like a true thing to me. So let's make a parser test. And let's find a definition. Okay, definition with a name. All right, variable reference. That's all we've done with definitions so far, basic definitions. Let's do the syntax test. Must only have variables left of equals. Okay, and this is an unsuccessful parse. Let's see, failed parse. Yeah. And I have no idea where the error is going to report from. All right, but if I say function x y equals x, okay, that's a legitimate function definition, and I want to have an error message that says oh no, that's legitimate. Let's put, well, I don't do operators yet, so what can I do to mess it up? 42. Right. Okay. So function definition has only variables left of equals sign. Okay. And that goes on error messages. I'm basically alphabetizing static let definition. I only have variables. Okay. And I'm not going to worry about the location. Must only have variables left. Okay. That should be fine. If that's the only thing wrong, we'll deal with that. I may not be able to get a location at this point. We'll see. We'll run all these. This should fail. Right, and what do we get? Well, we got a definition because it doesn't pay attention to that yet. Okay, so we're on track here. All right, so what I want to do so here I've done the parsing. It's a little primitive, but I've done it. And now I wanted to apply semantics on the path before it exits. Okay, so I want to enforce the semantics that only one of these can have. And we had a pattern for that. Let's see. I don't think I've been consistent. I know I haven't. Enforce if semantics. So I made the assumption that there would be a helper method that had all the complexity in it. And I think that's better. I don't know. Let's do it, and then we'll decide how to extract it. So what we're going to do is we're going to take expressions, inner expressions, and then we want to assert that all those are variables. Okay, and I think there's all satisfy. Yes. Okay, so the predicate is $0 is variable. All right. So if the expressions all satisfy $0 being a variable, that's the left-hand side. Okay. My naming may be backwards. I think this would be better off called LHS, and this could be expressions, but let's get it right first. Okay, so if expressions is that's everything's fine. But if not that, I guess I'll only present this, then I've got to return an error expression with error messages dot function definition blah blah blah, and then I don't know, do I have a location? I've got the token. We just called it location, right? Okay. Let's put the warning on the equal sign. All right. All right. I think I'm hoping just the location is wrong. A function definition may only have only variables left of the equals in line 1, column 4 versus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. That's all right. Okay. Forgive the laziness. Pass. Okay, now this one is much less problematic now. We know it's a variable because we got past here, so that's cool. Let's rename this. That's a bit awkward. Rename. How about function definition has only variables? Okay. A little better. All right. Now, what I'm trying to do, all right, let's commit this. Check that function definition has only variables left of equals. All right, now the next thing I'd like to do, so this here, okay, I'm feeling like this stuff, all of this is big enough to be its own thing. Okay, and I want to extract this as a method. Thank you for your support. Okay, so let's copy this. The method is going to be function definition. All right, we took this out. We can delete that. I'm going to put it here. We'll come back to it in a minute. Function definition. All right, this is the manual extract method. So you copy, you paste it in, you look at things and you go like, hey, I don't have expers coming in. I don't know what expers is, so I'm going to have to pass it in. So up here, we're going to take expers, which is a multiple expressions. Expers is a multiple expressions. Okay, now how are we looking? All right, no return value. Well, it's got to be an expression. Okay, cannot find expers. Oh, I didn't want all that. I copied too much. I only should have gone to this brace. Actually, that. Okay. So now, I mean, this is extracted. It's harmless. It's not being called. Okay, let's call it. All right, and notice it can return either error expression or definition. That's fine. All right, but it felt like it was becoming too much. Okay, so if I have that, then I want to return function definition with expers. Okay, and then I take out all this. All right, that should be refactoring. So first I extract the method, then I figure out what missing parameters had to come in. Hopefully there's no other side effects. We didn't have that problem because this thing just returns, the whole block just returns a definition. But notice what it does. This is immensely improved. So I can make sense of this a little bit now. Expressions, parse expressions, look for any errors. Okay. otherwise capture the expressions, pass them into a function definition, or pass them into what is apparently an expression or a function call. That is not sufficient code for the long run, but it's what it is now. All right, so let's capture that. So refactor extract function definition. And in Xcode, it's so much manual refactoring, I don't even bother trying to say something was automatic or not. All right. Now, my other complaint was I felt like LHS was a better name for this, but LHS is the name I use here. Okay. Let's call this, well, let LHS equal that, return that. Let's just return this. Okay. Instead of assigning it to LHS and returning it. Okay. That should be fine. And then I'm going to turn expers into LHS. First result isn't the best name either. Let's make this LHS. All right. And then I think this would be better. Expers is okay for it. So I did the transition in a way to kind of avoid making a mistake. So, okay, get the expressions, check for errors, capture it as multiple expressions. A little goofy. Return token, return a function definition if you can. Otherwise, return the thing we're doing. Okay, so this was refactor miscellaneous renames in. Yeah, we'll leave it there. Okay. All right, so how are we on our to-do? Definition must only have variables on the left-hand side. Okay, we've enforced that now. That's good. Okay, so we're knocking out a little bit of stuff. I almost titled this episode like I'm just lost in the dark because that's how it feels. That's redundant. Okay. Variable knows how many expressions follow it. We're still not ready to do that. Okay, can I... Let's focus on this function definition. So if we know that everything is variables, well, okay, so what I want to do, I've got the right-hand side, so I want to do the equivalent of this multi-lambda thing. So I want to do this transformation from that to this. Okay, so function xy equals x plus y is equivalent to function equals lambda x, lambda y, x plus y. All right, so basically, if I have stuff on the right-hand side of that function name, I want to transform it. I want to layer it with lambdas. Otherwise, I just want to return it as is. Okay, so if we just did var equals 3, there's no lambdas involved. It should just have 3 on the right-hand side. Okay. Right. So I think what we're saying is that we want to make a transform of, basically we want the rest of the arguments after that first one. And every time we see one, we're going to wrap it. And maybe we want to go right to left. Yeah, so we want to wrap y goes to x plus y and wrap lambda x goes to lambda y first. Okay, I think. Precedence of arrows is to the right, so I think that's what we want. All right, so the to-do is variables, definitions with multiple variables on the left, transform into lambda expressions. Okay. And we want to test that. Well, we'll make a definition with multiple expressions in it. Okay, so definition with, let's just start with one argument. Okay, function x equals 3. We don't care what it is, but this thing should now be a lambda. And we have a lambda there. Okay, let's borrow that. But well, integer value 3 will be useful in a moment. Instead of variable id, integer value 3 is probably what we want. All right, let me just stretch this. Oh. Okay, so definition x, well, no, it's a definition of function. Lambda expression x goes to value 3. How are we on parentheses? That, one more, that. Okay, so if you have an argument, does it show up as a lambda? Yeah. And we don't know the answer. I don't know why it broke into multiple lines there. Okay, function x equals 3, definition function lambda x 3. Yeah, I think that's a valid test. That should fail, to be clear. And you don't have to use x, right? This could just be a constant. It's no big deal in the right-hand side. Function lambda 3 is not equal to definition function 3, right? So the current version just takes the right-hand side, slaps it in the definition, and calls it a day. We're going to wrap it up a little bit in lambdas. Okay, so let's pull out this inner expressions. What would we call this? X versus the multiple expressions. It's like I don't even really want a multiple expressions. I just want the array of expressions. Let's change the way this works. So now expressions, I want to call it with multiple expressions dot inner expressions. And I'm just going to look at expers. Yeah, I'm happier. Okay. Right. So we've done the error checking. We've got the variable. Now we want to take this, which is really like names or parameters. Well, we'll just call it expers still. So if I take, what do I want to do? I want to take the expers dot drop first. So I'm getting rid of the variable dot, and I think I want to do reverse. Okay, so if I have function xy, reversed. If I have function xy and I drop the first, I just have xy turned into yx. All right, and that's what I want. Now, how do I wrap these? Oh. Is it reduce? I always mess up reduce. I'm sorry. Okay, so reduce takes an initial result. Well, our initial result is the right-hand side. And then it takes, I think it takes a function, right? Are you going to tell me? Come on. Let's do this again. Okay. Reduced. Next partial result. Okay, so next partial result is it takes a result and an expression and returns a result. Okay, so I've got an expression. So reduce with right-hand side and well, this is a lambda. And it's I can't remember these things for 22 seconds. I think it's value and next in. All right. And what we're going to do is wrap these things to closure type expression. Yes, we're going to wrap it with a lambda expression where name is next. Name and value, I think. Cannot convert reverse array to expected type string. Okay, this is variable. We know they're all variables, so all right, let's do this. Let name equal variable as variable. This tells me I kind of wish these things were already translated, right? All right, so lambda expression name value. Return that. Cannot convert variable. I'm confusing myself. This is var exper variable variable.name. Okay. And we're going to let new right hand side equal that and do this. Is that going to work if in the zero case? I don't think so. I don't know. We'll just see. I didn't take advantage of the fact that I only had one right-hand side member. I actually did what I think is the whole solution for the semantics. All right, let's improve our test then. If that really worked, then this should be lambda expression of x with lambda expression of y with one more parenthesis, I think. Yeah. Okay, so if I had x, y, I should get that. This still worked. Okay, so it did the right thing. I guess it would. Normally reduce gives you 0 if you do a reduce plus with an initial value 0. Okay. Wow, is that... I don't know if that's getting obscure. Okay. Now... expressions come in if they are all variables. Maybe I could do something here. What if I did... if I take the expressions, map each one to $0 as variable. All right. Now I know my left-hand side. I know I've got these variables. Okay, let's push this before we start changing it around too much. Okay, convert multi-arg definitions into lambda expressions. I mean, it's not so bad. Okay, so all right, so let's turn these into a left-hand side. Then I just need left-hand sides of 0. That's all right. Okay, now these things, if I take the left-hand side, which is a list of variables, I got a value. He's already the same type. Okay, so I can make this variable. And I can take out this return. Okay. Value. Whoops. Value. Oh, var expr. Variable. Okay. That should then be redundant. That should be okay. All right. What do we think? So variables left-hand side sub 0. Well, I'm only using that down here. Okay. I think I could do something better with this, but let's make sure this works. Okay, so we're going to take the left-hand side, drop the first argument, reverse it, reduce it with value variable equals, wrap it up in a lambda expression. And if there are none in the LHS drop first, then you just get the value, which is what we had before. Okay. Yeah, okay. I think that's an improvement. I should see if it works. Okay, now this one, there's another map out there that can do this. Well, first I just want to make sure, like, this reduce, it's not something you use every day. I mean, I kind of guessed lucky about the order and stuff, but reduce says take this value, use that for the initial seed, and then call your lambda, your closure, and pass in the current seed and the new thing, you know, from the list. All right, so if imagine this, we were trying to just do the sum, then the initial value, we would use 0 instead of right-hand side. So here, right-hand side is the whole right-hand side expression. If we have nothing going on with extra variables, we're just going to get that back and use it like we did before. If we have any, then we're sort of wrapping it with deeper and deeper lambda expressions, because this expression combines the old with the new and yields something that we can use as the old next time through the loop. Okay. What I think though is, I'm almost sure there's something that's like a filter or something like that we can use. This is, well, I guess is on list. Oh, it's display list. Ugh. What's the type of this thing? Well, it's going to be on array, yeah. Swift array. So what I'm looking for is a function that filters and transforms these values. Okay. And I don't see any reducey kind of stuff. There's drop, map. There's something that's like a conditional way of doing that. Ugh. I can do it in one line, but there's something that does it more directly, I thought. And that's part of the problem is, you do enough work in C# and Java and this and Swift and whatever, and you mix up all their little helpers for functional stuff. Just leaves you this vague feeling like this can be done. Well, there's filter. Really? That's a beta? Follow function. Yeah, I could swear there's something that takes an optional. Okay, I don't see it. Well, my idea was, what if I try and do this? Like, what if I said expressions dot map $0 as variable, all right, dot keep dot filter, nil. What does that give me? Variable. Let's try the other order. If we filter it, we keep the ones that are variables. No. I want to. No, it's not. It's. let's find that filter again. Element to bool. I think it's telling you which elements to keep. If I do this. Okay, so I only keep the ones that are variables, and I map each of those to a variable. This thing should be an array of variables. Yes. Okay. Now I know if this is the variables. Okay. Yeah. So how do I know it's an error or not? Okay. Anything that wasn't a variable means it was something else, means I return an error. So before, if they don't all satisfy being a variable, I get an error expression. Okay. Now I can do that with the count. If variables.count equals not equals expers.count, right? Then I've got an error. Okay, so filter out the variables, turn them into variables. If there are things that were not variables, then the counts differ and it's an error message. Okay, now LHS is really variables. And I think I can do this and maybe lose some issues. LHS expers.map to variables. So I think this replaces that. The only place we use it. Okay. And we could enforce it before the parse. Yeah, I don't know on that one. And we're not doing anything with the expression yet, so let's do that. Okay, so my argument is nobody references RHS until line 102. And this check on the variables, we're at the equal sign. We know what's to the left. We can check it right then. Yeah. I mean, you have to read a little more, but I'm trying to get it down to a simpler kind of thing. Now, the only simplification, I mean, I could say $0, $1 instead of variable and value, but I think they communicate something. Let's see if this passes. Okay. Now, at some point, I think this will become, we'll have to deal with the fact that our expressions should be multiple things. But I think we're in good shape. And I'm just putting the grammar up here. We're coming in with var plus equals, and now we're just doing the right-hand side and enforcing all the rules. All right. Okay, we went a long time. I'm sorry. I usually try and take breaks more like 40 minutes apart. Let's go ahead and take one last break. Well, let's push this. All right, so this is refactor, reorganize how LHS is checked. Okay. Good. Anyway, let's take a 2-minute break, and we'll come back and pick up from there. I think we're moving forward finally. Hey, welcome back. All right, so we've just added function definitions with multiple arguments, and we can run it. Our definition should be accepted, but we don't have a way to call it yet, so that's a little bit wimpy. But let's give it a go. So, those boxes should be colored differently, and we should start with our cursor in the bottom one. Let's add that to our to-dos. Story REPL should color top box gray and start cursor in bottom box. All right. At any rate, we should be able to say function x, y equals 3. Evaluate. Oh no. Wow, that's not much of an error message. How about function x equals 3? Ooh, 3. We messed something up. Okay. Wow. Error just as a message is not helpful. Oh, also we need a little more padding inside the top box. Well, that's disappointing. Okay. Why just error though? That's really :error. Well, if I see :space error, I think this is like some sort of unknown error. And colon means it's probably the type is unknown. I don't know. What have we done here that would... I would have thought this was... Oh. Yeah, for our case, let's see. Like this case, x equals 3. That should be fine. Y equals 3 is an error. Okay, let's find out why. The parse says it's coming back as a definition. With an integer value. All right, let's go to our definition. Evaluate. Okay, I'm gonna... I've kind of had it with these. Maybe this is a sign I've got too many node types, but you know, it's driving me a little crazy. Here's definition. Evaluate. Context at add name. Return empty expression. Okay. Now in the real REPL, returns a function, y equals 3 returns a number. I think it should be returning the right-hand side. Let's see what empty expression is. Empty expression. Yeah, who needs this? What am I looking for? Empty expression. Parser returns it in one place. Definition uses it. End of file. Well, okay. Definition. All right, let's get to our interpreter. Interpreter tests, definition tests. Definition. Okay, evaluating definition puts it in symbol table and returns an empty expression. Oh, we don't want that. We want the right-hand side. What do we want? Interesting. The REPL, the real REPL, I mean, it returns a function for a lambda, and it returns the right-hand side. So I guess what I'm hearing is a lambda just prints function and then its type, which is the type of the variable plus the type of the inside. Okay. So our case, evaluating definition, sure, put it in the symbol table. That's a good thing to do, but the result should not be equal to empty expression. It should be integer value of 42. This test will clearly fail. Okay, and we got nothing. We wanted 42. Okay. And somewhere his type has got to be the same as the right-hand side too. But that's fine. So we don't get that because our definition evaluator is lazy and just returned error expression or empty expression. Definition tests. Where's definition? Okay. So evaluate. I think it should return expression.evaluate. With the same context. All right, now I think the type may still be wrong, but let's see how that goes. All right, so if we run, and that makes me feel like we changed something somewhere, and I thought we had that working. Ooh, nice. Okay. Now, I think our lambdas, they don't print bracket function. Let's see what they do. So if we do function m equals 3, we would like this to say function, bracket function, colon, any goes to integer, I think. Okay, this is something like it. We print function colon generic integer. I think this should be the result of our lambda. I don't know where the closure is coming from, honestly. I mean, we do want a closure eventually, but I don't know. That's where I feel like we're a little balled up. Okay, but I would just like to print bracket function. That would be fine. And then if I print generic goes to number, I can live with that for now. We haven't straightened out our generic types really. They should get independent names and stuff like that, but that's okay. So closure. All right. So evaluating a lambda yields a closure, which should print function because it's an evaluatable thing, kind of. I mean, the closure just ties the symbol table to that. The type of a lambda or a closure, somebody's printing out function. All right, let's find that. Closure. He prints closure and then the lambda. Okay. Lambda as string. We don't really need that. I think we want our closure just print function. Bracket function. Okay. So this is kind of a debugging thing, but and I'm going to do it the backwards way. and see who breaks. And I don't know, sometimes I find it easier to do it this way, but Closure has closure in his thing. Closure tests. Well, okay, that's fine. I think we're now saying this thing should print function. As string, regardless of the lambda function. And this one, function call. Well, there you go. This is another one of those cases. We would like this to be closure.description. I think. All right, we had 3. No, just 2. Okay. So I think because we were using it in here with the full-blown thing, yeah. So again, this is one where James's pattern would have helped us if we'd just used it in the first place. Instead of making the closure, the function call case know how the closure is printing its description, we've isolated ourselves from that, but we're still assuming that the function call will call the closure description, so it's not a perfect isolation, but it definitely helps. All right, so we're going to make closures return function for their description. Okay. And if we run, I think we're still a little off. It looked like we'd get the word function there an extra time. All right, so we did function x, y equals 3. Function goes to function colon generic function generic number. Okay, so I think the left-hand side in brackets is our closure. The right-hand side is our Lambda expressions. And right now I think a Lambda expression says function colon and then prints its type. So we're getting there. I think the same deal. So let's see where our Lambda expressions, how they print. Okay. Yeah, we put off those generic whatevers. Where's as string? Okay. As string lambda name 3. I think this should print nothing. Maybe it's not here. Maybe it's the type. Let's find Elm type. Yeah, so a function, we print input type.description to output type.description. I think this word shouldn't be here. Okay. Again, I'm doing it the backwards way and seeing which tests break. I hope at least one does. Okay. It's nice when exactly one does, because it means you've done some encapsulation there. So I'm saying I don't want the word function there. The type is not function. It is something to something. Okay. And this should pass now. It's still not quite what I want. Right. So I think instead of saying generic, I would kind of like to just say A. Okay. And that's Beck and Elm type. So generic up here, even the word generic would be better, but I think I can just say A. All right. And it's going to be slightly wrong because there's times where it's not always A. Sometimes it's A goes to B goes to C. Yeah, so this should just be A. Well, I think again we're gonna Elm type dot generic dot description goes to let's do the same protection. Elm type dot number dot description. Okay. Oh, I should have run my test. Sorry. Everybody happy? Okay. How did I lose 4 tests? I thought I had 140 earlier. Oh, we folded a bunch the other day. Okay. Now let's run it. Function x, y equals 3. Ooh, this is nice. Okay, let's do it over here. Function x, y equals 3. Oh, come on. Function a, b equals 3. Yeah. Notice that the A is not our letter A. It's really the type A, which is a generic type. So if you did A of B, function A, B, you're saying, I don't care what 2 types it could be. It could be a Boolean and an int, A and B, because I'm ignoring them. I'm just returning a number. Let's do CD. D equals 3. Okay, yeah, it's still A, B. A and B are just the generic type names. And that's the thing we haven't dealt with yet is how do you know which types are allowed? So A to B to number says A and B can be different types. Over here, A to number says X and Y have to be the same type. Okay, so they are different things. I think the reality is our generic just says like, I'll take anything, anytime, and it doesn't really enforce that A is consistently A. So, on the other hand, this is looking like a real thing. I mean, that's much better. So I'm really bubbly happy with this. Okay, so we improved printing of closure function and generic types. All right. And I probably should count that in my to-do, huh? Okay. Variable knows how many expressions. Yeah. So we've done this. Okay. So this transforms into Lambda expressions. And improved printing for closure function, lambda, and generic. All right. I don't know. I feel these tensions in my body sometimes. You know, it's like if you ignore it, you're going down rat holes. Okay, so let's go back to Parser. So where we are with this is, I think this is very close to final form. The only thing I think is wrong right now is how we handle expression, because this could be multiple expressions, and we're not prepared to deal with that yet. I think it's the same problem as we have on any evaluation, but you don't evaluate it on a definition per se. You just evaluate the type. Okay. So where to go? So I kind of feel like the only thing changed that I expect to come then is expressions here, and the right hand side will wrap expressions and all that stuff. So I think it's close. But right now you can't do a function call on the right hand side because you only have one layer of expression. You might be able to, no, I was gonna say you could put it in parentheses, but no, still no dice. Okay, so that's really a very good. Okay, so now we're left function call or definitions. We get a bunch of expressions. If there's any errors, we dump them. If otherwise, we convert it to multiple expressions. Then we check for function definition, which is the stuff we just did. If there's no function definition, this is an evaluation. So we return the inner expressions. If there's only one, we return it. Otherwise, we know it's a function call. Well, that's a little optimistic. Oh, man. Okay. And that puts us back where we left off the other day. So that's why I'm... you're going to have to address it someday, Bill. All right. So what I would like to do is I'd like to work in how to get operators and function calls all together. And maybe I've gone too far in some ways. Like I might have been better off if I had just done int, lowercase name, maybe parentheses, maybe lambda expression. And because I got to get a function in there and maybe predefine some function sign or something. So one thing I can say is a lowercase name followed by an expression. And then somewhere plus operators. We haven't dealt with that. All right. So if I have a lowercase expression, so I'm trying to think if I did it the simple way, like our lambda expressions, you got one that takes 2 arguments, but if you only call it with 1, that's legit. But do we care in the parsing? And maybe that's what we got to do here is look up how many expressions do you want? I don't know. We don't want to accept more than it wants, that's for sure. But we can have less. That's not a problem. If our expressions are ints, well, what happens in here? Let's go to the real REPL. Okay, what is it? Reset? Erster? Okay, so I think I can say function of A, B equals A plus B. G of x, y equals x minus y. All right, now I can say function of g of 3, 4 to 2. Is that going to work? So am I going to get g of 3, 4 followed by function of that plus 2? I don't know. It feels a little wonky. Yeah. It expects 2, but it got 4. Now, I can parenthesize. But maybe there's something deeply useful in that. I mean, this should be legit. 3, 4 was... what was F? A plus B and x minus y. So 3 minus 4 is minus 1 plus 2 is 1. All right. But I can't call... Can I call function of G3, 4? I can. And if I say y equals that. I have z equals that. I can say z of 2 and get my 1 back. But see, fn of g34, it took one argument, even though fn takes 2. But the interesting case there was this 3 with a 4. It's like it just took all the expressions after it. So maybe this footnote is not correct. You have a 0 to as many arguments. I think we take that out. This really is this. Okay. So you had a lowercase name followed by a bunch of expressions. It's okay if you put parentheses and evaluate it, and if you have fewer, it knows what to do. So it's like it's sort of a reverse var args. You can have up to the number it takes. I think that's okay. Now, lambda expressions can do the same thing. Except in some sense, the lambda expression only takes one value. But I don't know. So what I'm kind of thinking is if you have function xy equals 3, you get a lambda x, lambda y goes to 3. And if you call that function of 3, right, so let's see, we had function is a plus b, right? Function of ab is a plus b. Okay, so if I do function of 3 applied to 4, that's the currying thing. So function of 3 evaluated like that is a legit thing. It returns a function and you call it with a 4. So what I want to know is if the expression on the left is a function, then that's what I think triggers it. This we can look up and say, is it a function? Yes. This we say, yes, you are a function. You may have, I think our grammar is this. And I'll parenthesize this too, just to be extra explicit. All right, so the two ways to call a function are these. Now you can wrap those functions in parentheses. You can pass literals. All right, so let's check that you can make the call. Here's lowercase name. He just returns variable. We know that's not right. All right. So I think what I'm going to do is I'm going to test this rule into existence. So we'll get this. A variable followed by arguments. Okay. This I don't think is true. Variable knows how many expressions. I think that came about, not the parsing, but I think that's a semantic error. So the story is really function call. And the thing we're tackling is this. Variable followed by arguments, lowercase name, expression star, or lambda followed by arguments. And that was this. Okay. And then this, I think this applies to any of them. It's more like function knows how many expressions follow it, but we think that is semantic. Okay, it's not, it doesn't appear to be driving the parser. So I was worried that we were going to have to really tangle things up for that, but I think that part's okay. Yeah. Okay. And then I think we're just going to start blending in some of these while we can do them. Okay. So I think we got 6 minutes. Let's do some REPL stories just to wrap up. I think the function call is going to be more involved if history is any guide. Okay. Color the top box gray. Or something. Oh, let's commit this. I didn't see what the difference in parser was. Okay, just to comments. Okay. So we'll just say nothing really going on there. All right, REPL. Content view. Okay. So, I don't know. These things, this is the model output. So I think I want the VStack. Padding. Frame width. What are you? You're the scroll view. Well, maybe the scroll view gets the background. 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 Light gray. No, it's going to complain. Color has no member, light gray. Okay. What do you got? Black, blue, gray. Well, we'll try gray. I think it's probably a little dark. Yeah. I know what I just did, but I didn't mean to. I think we can turn this thing off. Yeah, I only want that in the box. Okay, so that's way too dark. So I think if we put it on the VStack maybe, and then can I say color.gray opacity? No. Okay, that's on the VStack. Not what I wanted. Okay. Well, is this 975. Is not in the right place. Oh, maybe it is. We don't evaluate anything yet. So m equals 3. 2 plus 2. Oops. We don't have operators. Okay. And that's the scroll bar, I guess. Yeah. That's an improvement. Interesting. The padding is there now. It wasn't before, was it? Am I imagining that? No, it's okay. I don't know why I thought the padding was funny. Okay, let's take that for a win. I didn't need any padding. All right. Good. All right, so we'll stop here. Thanks for joining me today. I think we made some decent progress. The definitions kind of came together pretty well. The Lambda stuff falls out nicely of what we did, so I'm happy there. And we'll pick up next time. Let's see, tomorrow, Thursday, 1 to 3 p.m. Eastern Daylight Time. And I hope to catch you then or in the future. Thanks for joining. Bye-bye.